Neptune should be calm. It's far from the sun, frozen quiet. But instead, it is one of the most violent worlds in the solar system. Winds faster than sound, storms that appear and disappear without warning, and a planet that refuses to obey the rules. At nearly 4.5 billion kilometers from the sun, Neptune exists in a region where sunlight is weak and distant, a place where most worlds are expected to be quiet and frozen. By simple logic, a planet receiving so little solar energy should be inactive, slowly cooling and drifting through space like a giant block of cosmic ice. For years, scientists assumed this would be the case. Distance, after all, usually means inactivity. But Neptune refuses to follow that expectation. And that contradiction is where the real mystery begins. Despite its extreme cold surface temperatures, Neptune radiates significantly more energy than it receives from the sun. In other words, it gives off heat as if something inside is still working, an internal system that has not shut down after billions of years. This challenges traditional assumptions about how distant planets evolve, because many models suggest that worlds so far from the sun should have lost most of their internal energy long ago. Yet Neptune behaves as if it still has fuel left in its engine. Scientists believe this hidden power could come from leftover primordial heat trapped since the planet's formation, slowly escaping from deep layers beneath its atmosphere. Others suggest more complex processes may be involved: gravitational compression, internal chemical reactions, or exotic physics occurring under extreme pressure, where materials behave in ways we can barely reproduce in laboratories. Whatever the source, it drives massive atmospheric motion, feeding storms and winds that should not exist on a world so far away from warmth. And that leads to the deeper question, not just why Neptune is active, but what that says about planets across the universe. If a distant ice giant can remain this dynamic after billions of years, perhaps many other worlds we assume to be cold and dormant are actually alive with hidden energy. Neptune may not be an exception at all. It could be a clue that planetary evolution is far more complex than we imagined, and that even in the darkest regions of space, invisible engines may still be running. On Earth, the most powerful hurricanes can reach around 250 kilometers per hour, and even those storms are capable of massive destruction. They are driven by warm oceans and solar energy, which means their intensity is closely linked to how much heat the planet receives from the sun. Based on this logic, scientists once assumed that a distant world like Neptune, cold, dimly lit, and far removed from solar warmth, would have a calm, slow-moving atmosphere. But observations shattered that expectation in dramatic fashion. On Neptune, winds exceed 2,000 kilometers per hour, making them the fastest planetary winds ever recorded in the solar system. These speeds approach and sometimes surpass the local speed of sound under Neptunian conditions, turning the planet's atmosphere into something more extreme than any weather system on Earth. Instead of gentle currents, Neptune behaves like a gigantic atmospheric machine, where energy seems to circulate continuously through layers of gas, driving storms that can appear, grow, and disappear with surprising speed. What makes this so mysterious is that solar energy alone cannot explain such violence. Scientists suspect that Neptune's internal heat plays a major role, rising from deep inside the planet and feeding atmospheric motion from below. The interaction between this internal energy, rapid rotation, and complex atmospheric layers may create jet streams that accelerate far beyond what models originally predicted. In some ways, Neptune acts less like a frozen giant and more like a cosmic jet engine powered from its core. And yet the biggest question remains unanswered. Why have these winds not slowed down after billions of years? Planetary atmospheres usually lose energy over time, but Neptune continues to defy that trend, suggesting that its internal processes are still active and efficient. The planet seems to be renewing its atmospheric power in ways we do not fully understand, reminding us that even in the cold outer darkness of the solar system, worlds can remain dynamic, unpredictable, and very much alive. When Voyager 2 flew past Neptune in 1989, it revealed a planet that immediately challenged expectations. One of its most striking discoveries was the Great Dark Spot, a massive storm system roughly the size of Earth swirling through Neptune's atmosphere. At the time, scientists compared it to Jupiter's famous Great Red Spot, assuming it might be another long-lived atmospheric feature that could persist for centuries. The discovery gave the impression that Neptune, like other giant planets, might have stable, long-term weather patterns shaped by deep atmospheric dynamics. But years later, When astronomers observed Neptune again using more advanced telescopes, something unexpected happened. The great dark spot had vanished. It did not slowly fade in a predictable way. It simply disappeared. Even more surprising, new dark storms began appearing in different regions of the planet, sometimes forming rapidly and then dissolving just as quickly. This behavior was unlike anything seen on Jupiter, where storms can survive for generations. Neptune's atmosphere seemed restless, constantly shifting, refusing to remain stable. This unpredictability suggests that Neptune's weather is driven by forces that are more chaotic and less understood than those on other gas and ice giants. Scientists believe that powerful internal heat, combined with high-speed winds and complex atmospheric layers, may create conditions where storms form and collapse rapidly. Instead of being anchored by deep, stable structures, these systems may be more fragile, drifting and evolving as energy moves through the planet's atmosphere in ways we still struggle to model accurately. The result is a world that feels almost alive, a planet that changes its face over time. Neptune's weather doesn't simply rotate or persist, it reinvents itself. Each new observation reveals different patterns, new storms, and changing cloud structures, as if the planet is rewriting its own story again and again. In that sense, Neptune challenges not only our expectations of planetary weather, but also our understanding of how dynamic a distant, seemingly frozen world can truly be. Most planets in our solar system have magnetic fields that are relatively aligned with their rotation, creating stable protective bubbles that interact with solar winds in predictable ways. Neptune breaks that pattern completely. Its magnetic field is not only tilted at a dramatic angle, but also displaced from the planet's center, producing a strange, wobbling magnetosphere that shifts as the planet rotates. Instead of forming a symmetrical structure, the field twists and stretches in ways that make it one of the most unusual magnetic environments ever observed. This strange configuration strongly suggests that something unusual is happening deep inside Neptune. Scientists believe that beneath its clouds there may be vast layers of electrically conductive fluids, possibly mixtures of water, ammonia, and methane under immense pressure, capable of generating electrical currents. Unlike Earth's relatively organized molten core, Neptune's internal dynamo may be occurring in a thick, unstable shell rather than a centralized core, creating a magnetic system that appears chaotic and off balance. In a sense, the planet's magnetic field could be a direct reflection of its turbulent internal structure. The big question is whether this hidden magnetic chaos influences the atmosphere above. As charged particles interact with the magnetosphere, they could inject energy into upper layers of the atmosphere or alter how energy flows through the planet's system. If so, Neptune's extreme winds and rapidly changing storms might not be driven only by heat and atmospheric physics, but also by invisible electromagnetic forces rising from the interior. That possibility turns Neptune into something even more fascinating, a world where deep internal chaos may be shaping everything we see on the surface. If you enjoy exploring the strangest planets and cosmic mysteries, subscribe now. Because the deeper we go into space, the less normal it becomes. Deep inside Neptune, conditions become so extreme that familiar chemistry begins to transform into something almost unimaginable. Immense pressure and heat crush methane molecules, forcing carbon atoms to separate and rearrange themselves into crystalline structures. Scientists believe that under these conditions, real diamonds, not figurative ones but solid carbon crystals, may form and begin to sink deeper into the planet. What sounds like science fiction is actually supported by laboratory experiments that replicate similar pressures, suggesting that Neptune's interior could be a place where ordinary gases evolve into exotic materials through pure physics. The idea of diamonds falling like rain toward the core is not just a fascinating image. It may also help explain how Neptune generates internal energy. As these heavy crystals descend, gravitational forces could release heat, adding another layer to the planet's hidden energy budget and potentially influencing its long-term evolution. In a sense, Neptune becomes a world where extreme physics constantly reshapes matter itself. A planet where darkness, pressure, and time combine to turn gas into gemstones, fueling processes that may still be powering its mysterious activity today. Neptune releases roughly twice as much heat as it receives from the Sun, a fact that continues to puzzle planetary scientists. What makes this even more mysterious is that Uranus, a planet similar in size, composition, and distance from the Sun, does not behave the same way. Two worlds that should, in theory, evolve along similar paths display dramatically different energy signatures. Neptune appears active and internally warm, while Uranus seems almost quiet and thermally subdued. This contrast challenges the assumption that similar planets must follow similar evolutionary outcomes. Several ideas try to explain the difference. One theory suggests that Neptune's interior may be mixing more efficiently, allowing trapped primordial heat to escape through its layers and energize the atmosphere above. Another proposes that ancient collisions shaped each planet differently, possibly tilting Uranus and trapping heat inside, while leaving Neptune with a more dynamic internal structure. Whatever the true explanation, one thing is clear. Neptune once again refuses to fit neatly into existing models, reminding scientists that planetary evolution is far more complex than expected, and that even two neighboring giants can tell entirely different stories. Neptune teaches us that the universe may be far more dynamic and surprising than our categories suggest. Planets similar in size and composition to Neptune appear to be common across the galaxy, which means the strange behavior we observe here might not be an exception, but a pattern repeated countless times among distant stars. If one so-called ice giant can generate extreme winds, internal heat, magnetic chaos, and constantly shifting weather despite receiving so little sunlight, then perhaps many worlds we assume to be cold and quiet are actually driven by powerful hidden processes we have yet to understand. This idea changes how we look at planetary evolution, and even at the potential diversity of environments beyond our solar system. Maybe planets covered by calm blue clouds are not peaceful at all, but worlds hiding violent internal engines beneath their surfaces. Engines capable of reshaping atmospheres, generating energy and maintaining activity for billions of years. Neptune reminds us that appearances can be deceiving, and that the universe rarely conforms to simple expectations. And perhaps the most fascinating possibility is this. Worlds like Neptune may not just exist, they may be far more alive, complex, and active than we ever imagined. Neptune should be silent. Instead, it screams through the darkness with supersonic winds and invisible energy. It breaks the rules. It challenges science. And it reminds us how little we truly know. Subscribe for more cosmic mysteries. Because the universe doesn't follow our rules. And Neptune proves it.